So yes, I'm an ECE student, Electronics and Communications Engineering student at Bulacan State University, just a university here in the Philippines. On my university, we talk about analog electronics, digital electronics, but no FPGA. There's no ASIC. There's no IC. Maybe just the beginnings, beginner topics, but not very specialized. So I'm not really relying on it. I'm relying most of my knowledge on my hobbies projects and from this mentorship.
So he is an exceptional candidate, but that's good in some ways because the point is to try and prepare an engineer, a future engineer, to be as up and running as they possibly could be when they start their professional career. So in many ways, it might be more useful for lecturers and professors to teach perhaps more or less able candidates. But in terms of doing this one-to-one thing, it's worth doing it for somebody who's then going to really be able to use that information straight off the bat and step forward really quickly. Now I've been working with Angela. I know he can get a career probably anywhere he fancies in the world and do very well at getting a good position wherever that is, which he might not otherwise have had. And that's the difference for me. That if I was now an employer interviewing graduates, somebody says, well, I've done a RISC-V, which is impressive, and it's got this self-checking test bench, which you can verify because it's all checked in on GitHub, which just runs through a whole set of tests, now including the RISC-V international test, and says pass at the end of it. You think, well, you know, that's a great candidate, and we can trust him to start running and putting together. Yeah, if I was an employer and somebody had been through that step, and I could look on, they gave me links to their GitHub to show I could run the tests, I could look at the stuff. I want this guy. No question. No question.
I can say that these 8 months, it was a very great ride. From the start, I thought I did not expected to learn all of these things. When we started this mentorship, we were only talking about general things like front end, back end development of ASIC, nothing specific, not too complicated. But as we go on, like on our eighth session, for example, CPU, RISC-V, I'm already a third year engineer student, but I don't know anything about CPU. And this is the first time I heard about RISC-V. My first version of my project is just, I did a very simple CPU. Then as we go on, Sir Simon taught me things like automatic test bench and the test bench from RISC-V. I integrated it into my project. So I learned so many things. Not only that, we also talk about cache, virtual memory. I'm an ECE student, so I thought these things are like for computer science students. And these are not the things that would be taught at the university. I'm already at my last semester of my third year, and my university did not talk about any of these things. Sir Simon taught all the things that I would not learn on the university. Sir Simon taught it clearly. So yeah, it's not impossible to learn it. 1 hour, it's perfect. 1 hour every 2 weeks, it's perfect. It's the best opportunity for anyone here in my country.
Initially, I just was generally talking about chip design, the things that you don't get taught at college, you know, about self-checking regression tests, reviews, and revision control, and what the difference between front end and back end, and what the flow. And I put notes together, which you'd see if you read the diary for that. But it's when I started using slides and diagrams and stuff for the slightly more technical stuff, I think he enjoyed those ones more and got a hold of them. But we were also then started to move on slightly more advanced topics, which I did not, when I started this, expect to get to. So, you know, looking at caches and memory management units is beyond where I wanted to do the computer architecture and maybe generally talk about those things. But in my last company, we've done virtual memory stuff with Angela. I've tried to explain virtual memory in my last company to people, and I'm seen as a genius, and it's like, you know, it's too difficult for anyone else to. Yeah, yeah, but I did it with him and he's picked it up and he's understood it. And that's the point. He's the right kind of candidate, and anyone that isn't that self-motivated and autonomous in the way they do their studies.
So in the last 8 months, how much hours did you invest into the mentorship program per week?
On the first 8 session, like only 2 days per in fact 2 days per 2 weeks,
Mhm.
because I'm only reviewing his notes. But when we reached the part where we started CPU risk 5, I started my project on risk 5, and I'm doing it like 4 days a week, all day, and I have already like 7 hours of sleep because yeah, it's a great experience. This 8 months went fast. It is
Okay.
sad that's over. I will tell to my uh peers, to my classmates, that about this kind of mentorship, but I doubt it that they will be motivated. They must have done like 3 to 5 projects on FPGA, because if they did not do any projects, I think they will not be able to finish all of this mentorship,
Mm.
because some of these lessons are like complicated, or maybe they will listen to the teacher, to the mentor, but they will not be able to apply it. Because like for in my case, we studied about Python scripting, and as soon as we finished that module, that part, I already started applying it. I already did a Python script on my project. So it was all worth it because I can already apply it. But if some students will think that I will just apply it if I got a job, then maybe at that time that they got a job, they will already forget it.
No, I think, I mean, that's true. If a future candidate from wherever actually, I would have, yes, I think, I mean, he's right. We'd want to have at least demonstrated that off their own back, they've at least taught themselves enough from books. This is what Angelo did, taught himself enough Verilog and then tried to put a project together, which was at a state that at least demonstrated they can get something working on an FPGA. I agree that the sort of tutorial sessions and mentoring sessions that I did with Angelo were formed by the fact that there was a lot of foundation. If we'd started from somebody who hadn't been at that point and already knew enough about Verilog and FPGAs and generally logic design off their own back without necessarily forming it, then would have spent half of that time simply trying to teach them about logic, binary, Boolean, and that is really what a university should be doing.
So you made an interview with him before you decided to mentor
Yeah.
him.
So the main thing I tried to do at the interview was as if you were a graduate engineer, because we were talking about trying to do chip design with the back of my mind that he was only starting his second year. So he kind of got a lot of this stuff out of books, but in the stuff he did where he had an SRAM, he didn't have it as SDRAM. He just wrote an SDRAM interface instead, which is a non-trivial thing. It's not big, but it's non-trivial. So we talked about that. So it was that, and that's kind of what I was looking for, that initiative to say, I don't have everything I need, because he could have just copied this and made it work, which has still been fairly impressive. But that he took that and said, well, I need something else. So he just went and looked at the spec and did, isn't that low frequency, single-ended SDRAM, but nonetheless, that I needed somebody that could pick up stuff quickly and then in the interim run with it. And I found that in the interview. And I wouldn't go into this again without going into an interview process, I think. You wouldn't just say, I wouldn't take it on spec from an academic record or whatever, or even a list of things somebody's done in a project without then talking to them about, like you do an interview, normal interview, somebody says like they claim to have designed this. So you talk to them about it and it becomes quickly obvious that they really did do that and had some innovative stuff, or in fact they had a lot of help and were just one member of a team and they weren't necessarily the lead. And so I was looking for those kind of things. And I think that's how it worked out. So I know from taking graduate engineers on some of them come out with a lot of with good degrees and a lot of academic tuition. So I want to know that they've got some skills where I'm not spending my first year engineers around me teaching them how to do front end stuff or how to use CAD tools. So if they've used a simulator, if they've used a synthesizer, if they've used a layout tool, then I know, even though it's not the tools that I'm using, to me, if they're good, it doesn't matter, because my own experience in commercial and open source tools is they are trying to do very, very, very similar things. And it's usually just the semantics and the actual interface that is different. A lot of the stuff you already have in chipschool, the overview of process systems, SoC systems, the overview, having access to how to use synthesizers and layout tools, that is the thing, because it says, I don't then have to spend that money on my engineers' time to teach them that. They would just have to oversee, like, you've used Yoast before, here's our synthesis tool, and I'll spend an hour showing you the thing, and then they should be able to run with it, rather than somebody has to go and spend time teaching them not only the tool, but the flow and the process and what you're trying to do, what the pitfalls are. And I think the real benefit of chipschool as a complement to their academic studies is that you can put them to use straight away.
Would you recommend Angelo to companies to hire him?
Oh, most definitely. As I say, he's already, I believe, at a state where he's understood things that engineers of maybe 5 years experience still struggle with. I think as I say, with the initiative that he took on the RISC-V process, he's been through a mini version of a front-end design process, including, and that's what we did, a formal review. So I downloaded all his code from GitHub when he was ready to sort of say it's working to my tests. And he used the assembly language that we'd been through to write tests of his own. I said, well, let's do a review for me. So I will look at it and I will recommend changes in a category of nice to have and recommended and must fix. And we did that, and he took that, and if I was looking at employing, and I have done, young graduates, I would think, oh my gosh, he's a year ahead. I can immediately put him on writing scripts or taking over a test bench and adding tests. So I know I could already do that. And I think if I was an employer, for a small, medium or large company, which I've worked for all of those variations, that would be, and in particularly maybe even a small company, say, no, he's really useful, because he can do multiple things. He can do scripting, he can do simulation, he can do design, and he understands processes, and he understands an SoC system. Even you can design all of it. You understand how buses works. And I think matching that with the material you've been putting together on the list of the chipschool stuff about what's essential, potentially to be a good graduate employing opportunity. I think he ticks all the boxes, and I tried to match some of the stuff we covered to the chipschool stuff that was general headings that were listed, like Axie bus and processes and stuff and all of that. So I think, I definitely recommend him to anyone that came to and asked for a reference.